In this video, we're going to do a quick troubleshoot on a timer. It's going to be two parts to it. The first part having to do with the settings in the timer. This can cause a lot of problems, and you really need to know if everything is set up properly. And the second part is going to be an electrical troubleshoot. So get out your multimeter, and we're going to go through that in just a minute. But when you walk up to a new system, let's say you've been called out for a repair situation, or maybe you're doing a tune-up or a spring startup, the very first thing you should do is just take a quick spin through the settings on the timer. That can reveal a lot of problems if you're called out for a repair situation. But let's just say we're going out for a standard tune-up. Really, we should see if everything is okay inside the timer before we do anything else. And it's just an easy thing to do, and it'll only take us a couple of minutes. So let's go through this really quickly and talk about the different settings here. This is a Hunter X Core, and on different timers you may see this set up a little bit differently, but there's 4 factors of timer programming that we're going to touch on here. And I've got this information more in depth in other videos, but this is really just an adjunct to our troubleshooting course and just a quick way to go through and check everything out. So on this one, this is a system off position. This is the run position. And then over here, this is the first thing we're going to check is the current time and day. We need to know if the timer knows what the correct time and date is. It can actually make a big difference. So we're going to go through it on this one. We have our left and right arrow keys and a plus and a minus. So what we're going to do is click through this. It says it's 2025. It's June 27th. Okay, that's okay. And now we're going to look at our time. But one of the things that I really suggest you pay attention to is that over here it's kind of hard to see, and on some of these little small readouts it becomes very hard to see, is the AM PM. That can really cause some havoc if somebody's like, oh my gosh, my system's coming on at 6 o'clock at night. Well, it's probably just the AM PM is messed up, but we always want to check that. We're going to set our time, and of course with our plus and minus things here, that that's how you change your flashing value on almost all these timers. As you're using your right or left arrow key to click through the different things, you'll see what's flashing is what you're able to change with your plus and minus buttons. So we're all good here on our current date and time, start times. Now on these kind of timers here, pretty much all timers except for one Rainbird model, they work by having one start time that triggers the entire cycle. And it's very unintuitive, and a lot of homeowners make the mistake of putting multiple start times in here. And on this type of timer, like I said, almost all of them work this way. One start time is going to trigger the entire cycle. The timer knows to turn number 1 on, shut it off. Turn number 2 on, shut it off. But if we have the Rainbird SST, we've got a picture of it here, then what's the difference in this one is this is a timer that was marketed directly to homeowners through Lowe's or Home Depot or whatever big box stores there. And the way this one is set up is that you have to put a start time in for each zone. And it can become very confusing if you're dealing with both kinds. Just remember here that almost every time except for that SST, you're going to be putting in one start time. So it says 1 at 5 a.m. on program A. Okay, we have a program button over here, and we have generally A, B, and C programs. You may have more on better timers or more expensive timers, say that. But it gives you the option of having multiple start times throughout the day. Let's say you've just put down new grass seed and you need this system to run 5 times a day. Well, our start times and our different programs are how we're going to accomplish that. But under normal circumstances, generally you're going to have one start time and on one program, program A. So here we have a 5 a.m. flashing. If we want to change that, since it's flashing, we can use our plus or minus. But let's just click through and see if there's other start times. Number 2 off, 3 off, 4 off, back to number 1. But let's check our different programs. A lot of times you're going to find different settings in these programs, and that should be something that you ask your homeowner, hey, what was going on with the timing here? Why'd you have different programs running on this? And it may be the case that if you have a very large system, 15, 20 zones or more, you may have half the zones running on one program on one set of days, Monday, Wednesday, Friday, and then you have the rest of the zone set up on like program B for Tuesday, Thursday, Saturday. But under normal circumstances, we've got a 5-zone system here. So we're probably only going to have one start time. So now we've clicked it over to B, program B, and we're going to click through all of our start times. We don't have any there. They're all off. We're going to go to program C, click through all of our start times. They're all off. And we're back to A with our 5 a.m. start time. That's what we want. Now, next step is our run times. And this is each individual zone's run times. We've got number 1 at 10 minutes, number 2 at 10 minutes, 3 at 15, 4 at 20, 5 at 30. Nothing on number 6, that's fine. And on this timer, it tells you program A has a total run time of 1 hour and 25 minutes. Very handy to know. Okay, so now we're back. And if you need to change any of that, here's how you do it. Now, the fourth factor is your water days, okay? And I know it's probably going to be really hard to see on the video here, but on most of these kind of digital timers, it's going to either have a drop, just a 1 water drop for the days that's on, and it may have a circle with a strike through it for the days that it's off. That's pretty common. Or maybe it's just a tick mark or without a tick mark on some older ones I've seen. So those are our 4 factors, but we also just want to check if there's a seasonal adjustment. It may be called a water budget or other things like that, but really what it is just one way to control the entire system up or down, but we want to check that. And if it's anything but 100%, and then you probably ought to ask the homeowner or try to figure out why it's not on that. Because if they, let's say you run this all the way down to 20%, well, let's go back and look at our run times. Our previous 10-minute run time is now 2 minutes. Our previous 10 is now 2, 15 is now 3, 20 is now 4. So this is a way to control the entire system up or down based on weather conditions, but this can be confusing to a lot of people. A lot of people never use this feature. I just want you to check it. So let's continue on with our troubleshoot, and we've already got our cover off of our terminal block here. So the very first thing that you should do when you open up your terminal block is just check your wires. Make sure that everything is solid in its connection, even your power over here. On some of the older Rainbird timers or Weathermatic, they have little flip down catches for the wire. So just make sure that everything is fit all the way up in there and it's solid. But let's take a look at some of the things that may be going on your terminal strip here. Here's where the power goes in, and this is coming from our plug-in transformer, and it either has 2 or 3 wires here. There can be a ground for this, and in the US, generally green wire stands for your ground. We may have green wires over here in our multi-wire bundle, but you can tell if a green wire is for ground. This one here is 2 power and then 1 sensor. We don't have anything connected to this, but this could be a sensor for a remote. It's actually a remote terminal, not the sensor, but a remote. So if you see a wire there, there may be an additional something attached somewhere down here that is a sensor for a remote control. Now over here is where our sensor terminals are, and this is for a ground moisture sensor or a rain sensor. And you should really know with the timers that you generally work with or that you see the most in your market, you should know whether those timers are normally open or normally closed sensors, right? This one, the Hunters, are normally closed, so it has this metal jumper in here to keep this circuit closed. And if it has a rain sensor on it, when it gets too much rain in it, it opens up and then stops the entire timer. But we don't have any wires here, and we have a jumper. The next one is a common. Usually in the US on these systems, the white stands for the common and should be used like that. Doesn't mean it's always going to be like that. You know, who knows who installed the system, and sometimes they just put the wires in any way they want to. But usually white is the common. And since you need a circuit to complete an electrical, like a full circuit to actually run an electrical item, you have to have a hot wire and a common wire. So the electricity goes out on the hot wire and then returns back via the common, and it's common to all of the individual circuits, okay? The next terminal over is either a P or an M, pump or master valve. And that's if you have an external pump start relay or a master valve attached to the system. It'll have a wire here. It'll generally have a wire to that and an additional wire to the common to run the pump start relay or your master valve. And then beyond that, you have 1 through 6 here, or however many terminals, and these are your individual zone wires. So let's do a quick troubleshoot on this. Let me turn this back here just to our run position. We're going to get our multimeter, and the first thing that we're going to do before we turn it on is turn this to ohms. Okay, and this is going to be our resistance setting. So you're generally going to put that on the lowest resistance setting. On this one is 200 ohms. And what we're going to do is just do a check of all of the circuits. Okay, so put one of your leads on the common, and now we're going to go through and check our different circuits. Okay, on the PM terminal, it didn't read anything because that's an open circuit. There's nothing attached to it. But I do have valves on zone 1 and 2 here. Okay, so we've got 24.6 ohms on circuit number 1, and that's actually a Hunter PGV valve I've got attached to that. Zone 2, I've actually got a K-Rain valve on here, and it's the 34.1. And let's check the rest of our circuits. All of these are open. I don't have any valves attached to these. This is just a timer I've got installed here to do this video. But you're going to check all of these circuits, and generally between 25 and 75 ohms indicates a normal circuit, but you really kind of need to know, what type of valve that you have to get precise on that. For the Hunter valve, 25 is about normal on that. I think Rainbird is maybe 50 or 55 ohms. And that's what the measurement is here for resistance is ohms. And so again, for the Rainbird, the K-Rain is 34 ohms and nothing on the rest. So the next step would be to turn a zone on, and let's check the voltages. On the Hunter timers, a good way to do a manual start is just press and hold the right arrow key for 2 seconds, and it'll fire up zone number 1. So it's running, so we should be able to check the voltage. We're going to turn our multimeter to voltage AC and on the lowest setting. And generally what we're looking for here is around 24 volts AC. So what we're going to do here is we're going to check the voltage on our circuits while it's running. And the timer should be putting out voltage not only to zone number 1, in this case, we've got zone number 1 on, but it also should be sending the same voltage to your pump master valve slot. So let's check that. 26.8, 26.9 volts. Zone 1, same thing, 26.8 volts. But also check the rest of your terminals as well. This can indicate a problem out in the field. If you have, this one's showing 5.6 volts on that, that's probably just the timer putting out a little bit of extra voltage. I think maybe this timer might be going bad. It really shouldn't be putting out 8 volts or 7 volts on this. Generally 1 or 2 volts at most. But really what you're looking for is making sure that you've got proper voltage on the zone that's supposed to be running. Now, if you see 24 volts, 27 volts on these additional wires over here, it's an indicator, A, that there's a problem inside the timer, or there's a problem out in the wires. And a lot of times if you have a multi-strand bundle like this and they chop through it all the way, it doesn't actually break all of the wires, or it doesn't pull them far enough away. Let's say it breaks them through right here and a vibratory plow or a shovel cuts through it. Well, they may be close enough to where if there's some moisture in the ground, that there's actually some signal that comes out of the wires that are on and then feeds back into the wires that's not supposed to have voltage. So that's really what we're checking for there. And I really need to check this one out. It feeding a little bit of extra voltage across through here isn't necessarily a bad thing, but if it would be like 24 volts or even 20 volts, we know we'd have a problem. So let's advance to zone number 2, and let's check our voltage on it. Okay, put it on our common. We're going to check number 2, and that's 26.6 volts. Our pump master valve terminal, 26.9. Nothing on 1. A little bit of voltage on 3, 4, 5, and 6. A little bit of voltage here. I don't think that really indicates that the timer is bad. It shouldn't be causing any problems. But like I said, if you're seeing a lot more voltage on these other ones that's not supposed to be running, then you've definitely got a problem. And this is just our basic quick troubleshoot. If you've got further problems, we may need to get down and do some further things here, but really this is how you're going to check your voltage and the resistance of each of your circuits.